Hey everybody, this is Larry. I'm doing this problem as part of a contest, so you're gonna watch me live as I go through my dots as I'm coding. There'll be an explanation near the end, and for more context, there'll be a link below on the actual screencast of the contest. How did you do? Let me know how you do. Hit the like button, hit the subscribe button, and here we go. So that was pretty good. Um, a little bit relieved, but yeah. But this is Q4. I've gotten it. Excuse me. Q4, allocate mailboxes. So this is a dynamic programming problem. Just also as a reminder, you can fast forward to the end where I actually explain this problem in depth actually. But so what you're going to see in the next like half an hour even is just me doing this live and me explaining my thought process as I'm trying to solve it. And I took a long time to figure out this problem, so the commentary is going to be just as long. But if you're here just for the solution, definitely go click on the links below, find the answers, and then let me know what you think. Cool. But yeah, allocate mailboxes. So this one, I had a couple of things to that I wanted to think about this one. There are a couple of things for this one to think about. It's dynamic programming. I knew that it was some variation of dynamic programming. Total distance. Okay. I didn't know. Oh yeah. So initially, I thought that you have to return the maximum min distance, which you can solve with binary search, because then you just search like, hey, is the maximum distance 10, and then just greedily put houses down, right? So that would have been one way to do it. But then I was like, oh wait, no, it's the minimum total distance, which is a different problem. So I'm really happy that this time I solved the right problem, because there's been a couple of times before where I rushed it and then I did not solve the problem fast, or like I solved the wrong problem and I had to rewrite it from scratch. So for that, I am happy about this one. Yeah, so there's an observation that I am trying to make here. Some of that is because I have solved a similar problem in the past a long time ago, so I don't remember it exactly the details, but I do remember, I do have some recollection of it, and that's what I'm trying to think to myself. Like I have what I call you're given this problem, right, and you have this texture. And what I mean by texture, and is a word that I use that I think no one else does in any way. So, so if you hear, it's from here. But what I call the texture of a problem is that, and why I call it a texture is that you have this feel when you see a problem and when you sense a problem, and you feel this problem, and you have some intuition about some properties about this problem, and then and a lot of times this will come from previous practice, observations that you made last time and you proved to yourself last time, right? That it is correct. And for me, I did probably do something like that last time, but that was a long time ago, possibly years ago, possibly decades ago, when I last solved a similar problem. But I did still have that intuition. I still have that, like, hey, I think this may be true. You should take a look at it. And that's kind of how I thought about it. And my intuition is and you can do this mathematically as well. There's nothing like, I don't want to make it too too mythical about like all these experience and so forth. But what I want to say is that that it always makes sense to put. So yeah, so there are only a couple of cases to break it down. One is you put a mailbox on a house, or you put a mailbox between two houses, or no houses at all, right? So those are the things that I would think about. And then the reduction that I was trying to think, and again, I go over this in more details later in the explanation. But I was just trying to convince myself at this point. Okay. The first thing that I did was sorting the array, so that it's from left to right is increasing. That makes sense, I think, in a sense that if it's out of order, it's a lot harder. So, so the first thing I was trying to think, right, was what I just said, which is that that when we put it that way, where we could put a mailbox either on a house, in between a house, or not between these two houses, so you have to put it in the forward, right? Once you do that, it breaks down the question of like, okay, yeah, it breaks it down a little bit. But I did actually before that, I forgot about this. Sorry about this. This commentary is a little bit of my memory. But what I try to think is, okay, let's go from left to right and then do some divide and conquer, right? Like, okay, what's the maximum distance of left and the right if we put a mailbox here, right? And then I was going to think about maybe doing it that way. You could maybe think about the same idea for burst bubbles or something like that, or burst balloons. Yeah, and those kind of problems where you divide and conquer dynamic programming. And then the reason why I stopped was I was like, wait, because we're given a k in this problem, then the short answer is that it's going to be too slow. Too much space, too slow, because it's going to be n to the fourth. So I was like, that doesn't make sense. So then now I pivoted to the, okay, because you can always process a house at a time, either putting it in the beginning or at the end or whatever. Then yeah, then you can just process the houses one at a time. And that's kind of what I try to do. I would say though, I did have a little bit of a. I didn't understand this problem in the beginning, even though I got the code say 80 to 90% correct, but it wasn't 100% because I was missing one understanding of the problem, which is which is the edge cases. I think in dynamic programming and sometimes in sliding windows and stuff like this, it is very important to think exactly how you want to define the problem. And what I mean by that was that what I mean by that is that because my index isn't clear, even though I wrote the name of my method is getMin, I have the index, I have the k, and it's mostly right, but I wasn't thinking about like what does it mean? Is it like, do I put a house on index every time? Do I skip index? Is the last house on index? So these are things that are nuanced and obvious to ask, but if you don't ask yourself, then it affects your base case. It affects a lot of things. And for me, my issue was just thinking about what the index actually meant. And even though I was really correct because I was mostly correct, but not 100% correct. But I was mostly correct because I was carried by my experience in a lot of way. Because of my experience, I was like, oh, I think this is roughly right. But I wasn't able to be actually right, which is the more important part, because I didn't know how to define my edge cases, because I didn't really define the problem. And when you don't define the problem, it's hard to define the sub-problem, right? So yeah. But yeah, so at this point, and even though the code will look really similar from this moment in time and the end result, what I said was still true, which is that I didn't define the problem very well. And because I didn't define the problem very well, and also I have a typo, but because I didn't define the problem well enough, or I just didn't define the right problem, even though the code looks very similar, I wasn't able to solve it in a long way. And you will see me try to hack it to solve that for that reason. But the short answer was that I didn't define it. And how did I define this problem? The getMin for me right now is a sort of a prefix. Okay, so basically we have no houses and we just put in an index. What does that mean when we put in an index? Or like a house on house of index, right? So I do this thing, which actually was wrong, is wrong, still is what it was wrong and still is wrong. But basically what I was trying to do was, okay, let's say this is the closest house to up to y, up to house y. But I was doing this in an asymmetric way. I assumed some kind of symmetry where where it's asymmetric. So this was not right. And here in this point, I just wanted to run it just to kind of see if it works. I was just being dumb because I returned infinity in at the bottom of the function, so it was always going to return infinity. Took me a couple of minutes to debug this, which is unfortunate, but yeah. So now I saw the one case where it's wrong, so I looked at it. I was like, okay, what is what's up, friends? Um, I was like, oh, it returns correctly, but it's just like I said, it wow, I spent a whole 2 minutes debugging a typo because I just returned infinity like at the bottom of the function instead of best. I think now I realize this after I type this out, but again, I'm gonna blame it on my jet lag and rust. I was like, oh, this returns 14. Why does? Yeah, okay, silly Larry. So I printed it out and I was like, okay, it gives me an answer. It's not the best answer, but that's okay. I just wanted to. I knew that I was missing some stuff, but I just wanted to see how what's up. And so the reason why this didn't work was I was thinking about because we always put an index. Oh, jeez. That was the doorbell. Sorry about that, and it scared me a little bit. Hopefully, I don't know. Usually, I don't get anyone visiting, so it probably is just the mail or something. Um, but yeah. So the reason why this was wrong was that I always, and this is what I was talking about earlier about being clear about how you define the problem. I didn't define the problem clearly, so this is the issues I'm running into. One of the two issues that I would have to fix, and those two issues cost me like an additional half an hour and a wrong answer. So 35 minutes of penalty because like if you look at this code now, it's very similar to what I have later. But I was just missing the clarity. And what it's saying is that because I forced myself to always put my house down on the current index, I was trying to get away from that. I'd be like, okay, let's say I don't put a house on the current index, and that's what this if statement does. And I was like, okay, this looks good. Is this good enough? No, because that's the wrong answer, I think. In a good way, because I would have totally submitted it. And the reason why this doesn't work is because the way that I did the totals, if you process a house, you don't just take the delta, you have to take the delta of all the other ones, right? So that's basically what I did. But this is still wrong. What I did was a hack, and I was just lucky that it passed the system testing. Oh, not the system testing, the example cases. Because I knew I was thinking about this going forward, but yeah. Um, But yeah, so I did figure this out now. I submitted, and it was a little bit sad because I was like, okay. So the first thing that I questioned was whether oh, I did actually. Sorry, there was one thing that I missed, which I again do talk about later in the explanation. So definitely fast forward if you want to go to it. But was that that in between two houses, the best way to place
couldn't prove that I needed
a mailbox, if you want to put it between the two houses, it is equivalent to putting it on one of the houses. And I will, and in the explanation later, I will show why that is the case. But that's the observation that I made, and I was thinking through that is why that's an observation that I made, and also something that I just have experience in the past, so that basically in the past allowed me to kind of do this, and then the reason why I'm bringing that up now is that as a result of this wrong answer, I was just double checking, and I actually later in a couple of minutes will take a notebook to kind of look it up, because I was second doubting, like, hey, I do have recollection that this is true, but maybe it's not. Maybe I need to prove it again. And then I did prove it again later on paper, but I was a little bit doubtful. Like, I was like, maybe you do need to put the mailbox in between two houses instead. But you could prove to yourself, and I will show it a little bit later, why it always makes sense to put it in a house. But what happened was that I was double counting some of the stuff, and what I mean by that is that given this case, I don't know, my formula is just wrong. That's pretty much it, because I don't keep track of what's on the left, and if you just multiply it by index plus 1, it overcounts the stuff that are matching to other houses in the past. So that's why this is wrong. Yeah. So at this point, I am going to skip ahead. There'll be a link below so that you could skip ahead with me. But basically, I go through this and I do. I write on paper and try to prove myself that's correct. I will see you after the skip. If you want to fast forward or if you don't want to skip, that's fine too. Watch Larry struggle. But that's just my heads up. Where do you put it? That's the question. I should get 12. I don't get why it's 9. Oh, I see. Okay, I see the 9. This is not quite right. That's too slow. That's what I was wondering before, but I guess when you need it, you need it. That's too slow, I think, and I got a phone call. Okay. Seems too slow. Yep.
missing one thing. This is 9, right? And this is 8. This is not right. This is not right. Same complexity.
Hey, so getting right back to it. So I think at this point I was trying to figure out different formulas to kind of solve this problem. Um, but I think at the end of the day, I just did not have, still at this point, not a good clarity on how I define my dynamic programming function. And I was trying to, the last 10 to 20 minutes, what you saw was just me hacking away, trying to be like I said, like sometimes you're 90% of the way there. You're like, okay, maybe I could just, you know, YOLO, try different things, and the 10% will magically appear. And sometimes, if you have enough practice, that will happen because your intuition and your experience takes over for you in a way that you might not have realized. But if you don't formulate the problem correctly, you're not even trying the right things. And that was my problem. Even though my code, as it looks now, would be very similar to what it looks later, the formulation changes the base case, and the base cases changes the formula. The formulas, will be why I was wrong. And here, what I realized was that I always put. So I mean, if you watch what I was trying to do, I tried different ways to kind of get around needing to put a house, or so I put a mailbox on every house, and on the first house even. But then I was like, okay, how do we deal with the beginning case, right? Well, the beginning case would be that, your first house. So that's what I was like, okay. And it took me a long time to get to this point, was just separating out the test cases or the edge cases between the first house and the last house. And the first house is, as you can see, I just put a for loop to fix that first house, where I'm like, okay, let's put it in the first house. And then my formula is actually still wrong. But because I still didn't formulate the formula correctly at this point, I was able to kind of start to formulate the problem, but some of that it's still kind of, because I was doing the same. I was just trying to do the same thing I was earlier, but a little bit different, right? So that's why. And I just ran it just to see it. I mean, I knew that wasn't going to be correct, but it gives you a sense of. It tries to give you a sense of like the feeling of a problem a little bit better, and that's what I was trying to do here. But yeah, now I beginning to formulate this in a different way, which is, let's just treat, because before that I was trying to put the houses, like I was trying to do things too cute in a way, in a generic way, such that I was trying to do things in a way such that the first house and the last house,
Just
what you call it?
9 or something.
The first house and the last house the same way, right? Like I was trying to make generic how we handle the first house and the last house. And in a lot of dynamic programming problems, in my experience, you can do that. And some of that is because I maybe haven't practiced the harder dynamic programming problems in a while. So that's, again, talks about practice. Like Larry, and that's what I hate about when people talk about patterns and stuff like this, is that even when you don't consciously try to do patterns, sometimes you do fall into things where you're like, okay, like I've done, the last 20 dynamic programs were like this, why is this different? And if you don't, and it took me some time too as well, if you don't think back and be like, okay, how do I fix this, or why is this wrong, or have the components to build this up correctly, then your edge cases are wrong, and that's how I was not doing it correctly. And I was still not sold, as you can see, but then I was like, no, this is right. Or maybe not, I don't remember what I was thinking, because I was going back and forth clearly. I just wanted to see the answers, and I was like, okay, this is clearly not even close to right.
Today's just not my day.
But one thing is that my base case formula is wrong. That's why I was having a little second weirdness about this. And then now I'm just rethinking, like, okay. And on line 31, that form is wrong because you're supposed to for loop. The distance from, like, the cost of putting the first house at Y is the distance from the 0th house to Y, first house to Y, second house to Y, and so forth, right?
I just have an off by 1.
But I do not do that. And I thought that this one I was a little confused about. I think I was just a little off by 1, so I was like, oh, I just need to, but the formula was just wrong in general, so. So it was the formula that was wrong, but I wasn't certain about. I was still stuck on that prefix formula, but I definitely did not need a prefix formula. I was like, no, this is, and I just undid some of the stuff, but. And then here you see me kind of just going back and forth, and kind of the really surprising thing is that right now, I mean, I know that we've been at about the same amount of code and same amount of percentage. For a long time, but right now it feels like
sense, does it?
It feels like the end, and we're only a couple of minutes away. Like it feels like we're stuck, but it only took a couple of minutes until I submit this problem successfully. So sometimes grind through it. What I want to say is, grind through it, work hard, because sometimes the solution is just a couple of minutes away, even if you've been struggling for a long time. And here, you will see me soon come to the realization that my formulas are just like, what am I doing, Larry? Why am I doing this? I've been like trying to go for this the last 25-30 minutes because my formula was just a little bit wrong, or a lot wrong, and I just needed to second guess. I was like, this cost doesn't really make sense. Like I was trying to. So this is a common concept that comes up in dynamic programming, and that's why I was trying to figure out how to do it this way, which is that these costs, you could break them up from different components to sum it up together in an easy way. And when you do that, why do you do that? The reason why you would do that is because it saves you of n times. I explained this a little bit later again in the explanation, but basically, if I had did it the naive way, it would have been O to the n to the 4th, and we need to get it to n cubed, and that's why. And that's the reason why I was struggling a lot with this. But then, at this point, now I was like, oh wait, you could just brute force this, or not brute force this. You could just pre-calculate this, and that's kind of what I did. Well, the first thing I did was I wrote the right formula for the first house, because you saw that the formula was just incorrect for a long time. But yeah, now we're subtracting it from the index instead of from the left, because we've just got that wrong for a while. Yeah, I was like, do I need this? I could just put it in the for loop below. But then I was like, yeah, it's okay. Just
This is kind of true.
just leave it. It's fine. And even though I did an LRU cache here, it is not necessary because you only ever do this once for every function or every input. I believe. And then I was just trying to think about like the between the left house and the right house, and then for this one, I was like, oh wait, no, you don't need that um, because this is the first house. You only use it for the first house. Um, Here is where I need it, and that's where cost two is a crappy name, but and I was still thinking a little bit about how to merge them together in a good way, but at the end I just broke them down to two different functions, and then I was like, okay, this is just cost index of y, and then now double checking the index, I was like,
Oh, that's not right.
okay, double checking the index after this. um, but at this point I was wrong on so many things that I was just like taking my time, like in the beginning the 5 minutes would mean a lot of difference in rank, but here I was just like whatever at this point. And then I was like, oh, no, you double count index, so just 2 + 1, yeah. And then I was like, oh, that looks good, and then I submit and it actually works. So like I said, always keep fighting. Chatting with other Larry, explanations coming up, and I will see y'all. Well, the other Larry will see you.
That was dumb.
I just tried to find shortcuts of the maths, but I didn't find one quick. Oh. Q4. Let me adjust the mic real quick. Q4, allocate mailboxes. So this one I really was sad about. Mostly because I knew what I was doing and I knew what I wanted to do, but I just didn't, for some reason I didn't do this thing. Here, I was trying to put everything into one formula, and that's why I was wrong. And that's why I took a long time on this problem, because I think I got the rest of this pretty quickly, and I really probably should have done this a lot faster. But I think sometimes sometimes practice and experience comes together in a weird way. And what I mean by that is that I have solved a similar problem before, which allowed me to figure out the properties and the constraints of this problem a little bit better. But because I solved this problem before, I had a wrong or just a little bit incorrect memory about how to do it in a linear way, and as a result, yeah, and as a result, I was not able to do it in a very good way, because I was missing this function that I implemented later on when I was like, well, when I really break it down to its components, I was like, this is obvious. But at the time, I was trying to figure out in one formula or one way of doing it, which was not right. And if you look back at the code, you'll see that was clearly not right. But the idea, the main observation, the hardest part about this problem probably is noticing that, and I think in the examples they give you like they put it in between houses, but the answer is you don't actually need to care about between houses, because let's say here you have to decide between 5 and 12, and do you put on 5, do you put on 6, do you put on 7, do you put on 8, do you put on 9, and so forth, right? And the answer is actually it doesn't matter. And what I mean by that is that, well, everything left of the 2, let's say the 2 and the 3, how do I say this? What I mean is that how do I say it? Sorry, I'm just trying to think about a way to explain this. Let's say we want this for 1, right? What is the answer? What is the best way to put it? 25? Don't know what that means. But the idea is basically that if you were to choose between 5, 6, 7, 8 all the way through, it always makes sense to either choose 5 or 12. And what I mean by that is, let's say you're choosing between 5 or 6, right? Well, there are more numbers to the left of 5, so it always makes sense to choose 5, right? Well, in this case, it's not true. But okay, let's just say we have more numbers, and obviously we sorted first. I don't know if I mentioned that, but let's say we're choosing between 5 and 12. Well, here, let's say we choose between 5 and 6, right? Well, if it's 6, then if it's 6, there's 4 numbers to the right of it, 3 numbers to the left of it. So versus 5, well, 5 has 2 numbers ahead of it. So we definitely want to go 6. And then you could use that same logic for 6 and 7, and then 7 and 8, and all the way through. So all the way up until 12, a critical point, if you will, where it may change, because then now you have to change the equation of what's on the left and what's on the right. So knowing that, making that observation, which I had known beforehand because I practice on similar problems, from that, you know that you always want to put a mailbox inside a house. Okay, so now we simplify the problem a lot, and the question becomes, okay, given these houses, which k of them do we put a mailbox, right? Well, here we then just do dynamic programming, where the state is this is the number of mailbox left, and this is the place to put a house. Or what is the best case where index is the last house? I think that's what I want to say. And there are a couple of edge cases for sure, but the cases to break down. But basically, let's say we already have a house. So this kicking off function just gets the first house. It's like, okay, this is in essence a brute force of, okay, let's try putting a house here, and then the rest, it's a subproblem, we ignore it. Try putting a house here, the rest is a subproblem, we ignore it, right? And so forth all the way through. And then now let's say we have a house, let's say the index is on 5, and we do this recursion on getMin. Okay, now let's what our recurrence is. Okay, let's say we put a house on 18. What is the cost of putting a house on 18? Well, 12 will have to choose between 5 and 18. 20 have to choose between 18 and I guess nothing, but which is how 20 has to choose between 18 or a future house, or a future recursion, and that's what this recursion does after we put down a house. So basically that's all we do. So this cost2 function basically just gets all the numbers that are in the middle, and then the cost of all the numbers in the middle is whether it goes to the left house or the right house, and then we iterate through that. So here, let's say we have 20, 18 will go to 20, so the cost is 2. With 12, the cost is 7 because 12 is closer to the last house, which is 5. And then we just do it the entire way. And then at the very end, if we have any house left over, then we just go to the previous house, which is what this does. So those are the two houses, the two cases. And then now the cost2 is just like we said, the left house is here, the right house is on the index, and then for each house in between those two indexes, we just see which one is closer, right? Is it closer to the left or is it closer to the right? And that's the cost function for that. Okay. And then, so that's pretty much it for this problem. I mean, it's easier said than done. So let's analyze the complexity, right? Well, how many states are there in getMin in this function? Okay, well, index can be from 0 to n, and k could be also from 0 to n. So the number of states is n squared, right? Or n times k if you want to be more specific, but because k doesn't have to go all the way up to n. But I'm just thinking about worst case scenario in terms of, well, can we implement this, right? And then here we also go from index to n. So this is also, because we have a for loop of O of n, each element takes O of n work. So this is equal to L of n squared times k, or in the worst case scenario, O of n cubed, right? And then you may ask, well, don't you have a cost2 function here? And this cost2 function does a for loop, right? Well, so there are different ways to do it. So there are different ways to figure out how to do the math. So another way you could have done it is just by writing this. But let's just say because we have a lookup table, we cache it. This is O of 1. We'll get to it in a second. And since this is O of 1 because we already have a lookup table, then the work is still O of n. Otherwise, it's O of n times O of whatever this cost is. And in this case, it's O of 1. So this is O of n. That gives us O of n. And then this gives us n cubed time. And for space, well, the space is much easier, right? It's just n squared because that's the number of possible inputs. And for each one, we save one copy. Cool. And then now we have to get to this. How do we make this O of 1, right? Well, it's O of 1 core. After you finish doing everything, this is O of 1. Because, and this was not necessary, by the way. I noticed this afterwards that we only called it here, which is the inverse of this, but I'm not going to change the code. It's fine. During a contest, I mean. During cleanup, you should clean up your code. And when you're in an interview, try to keep it as clean as possible. But yeah, but here we do a similar, you could do it with a pre-calculation with for loops, because for example, you could, instead of doing this, you could just have like for left in range of 0 to n, for right, or for index in this case in range of 0 to n. And then you could put this for loop inside here, and then and just populate it, right? So you could have done something like this. So this is also and then like a cache of left index is equal to total, and then this one would just be a cache lookup, right? So I was a little bit rusty on this one because I struggled with trying to do it in linear time. I knew that I needed to do this, but I was trying to figure out how to do it in a constant time, and I forgot that I should just pre-calculate this. That's what a lot of my timing went to. But yeah, so this is converting this to this, but how would you analyze this as complexity? Well, same thing as here, right? So left can be from 0 to n, index can be from 0 to n, so this is O of n squared states, and each core does O of n work, because there's an n for loop, and these operations are O of 1, so each of these have O of 1 work, O of n work, so that equals to O of n cubed. And because your algorithm is going to be n cubed anyway, this is fast enough, and doesn't really worry about it. So yeah, so that's the running time complexity, and obviously also this is n squared space. Let me know in the comments if you have a question about that. But yeah, that's all I have for this question. It's a really hard interview question because there's a few things that you have to realize and learn. I don't think it's a fair question for an interview. It's a little bit hard. In terms of competitive programming, it should be straightforward. I took a long time. I took about 40 minutes on this problem with a wrong answer. And I felt like, to be honest, I got most of this, but I was missing this minor thing with the optimization because I was trying to put it in 2 for loops, and that would make it n to the 4th total, because here, if we had a for loop, then this would be n squared, and then this would make it n to the 4th. but then I remembered that, oh, I could just save it, and that took way too long, unfortunately.